Hello everyone, today I would like to show you what is the unit impulse function. Unit impulse function, also named as the direct delta function. Okay, now let's look at what is the impulse function. Okay, the symbol of the unit impulse function is called delta t. Okay, how does the delta t looks like? If I plot a graph like this, okay, this is the t. So what is the delta t? Delta t, okay, delta t, if I plot for delta t, that would be equal to 1. So this is delta t equal to 1. Okay, but if I have the 2 delta t, this means that if I have 2 delta t, means that delta equal to 2. So this is 2 delta t. Similarly, for 3 delta t, the delta t equal to 3. Okay, now you know what is delta t. Okay, if delta t means that at t equal to 0 and when t equal to 0, delta t equal to 1. So that is delta t. Apart from that, there is always 0. Okay, so this is the delta t. What if that is the shifting of the unit impulse? Okay, what is the shifting of the impulse response? For example, this is delta t, and then let's say you have a here. This is the a equal to 1. Okay, so what is this? This is actually a shifting. It's a shifting of the impulse response. So when t equal to a, this delta t minus a. So we have to write if this location here is a t equal to a. When t equal to a, so delta t minus a, because it shift to the right, so it's t minus a. It shift to the left is delta t plus a. So now the a is at the right, so it's t minus a equal to 1. Okay, so shifting. Let's say if you have the delta t equal to at the left hand side. So this is 2, for example. Okay, I make it longer. This is 2. So this is minus a. For t equal to minus a, this delta t plus a equal to 2. Okay, you understand now? Okay, now let's look at what is the shifting property of the unit impulse response. Okay, so it's a shifting property. What is the shifting property of the unit impulse function? So I would say unit impulse. Okay, for the shifting property, you need to know that there's a formula. The integration p to q ft delta t minus a dt equal to fa. For p must in between for a must in between p and q. So this is the theorems for the shifting property. Okay, now let's look at the example. Evaluate the integration from 2 to 5, t power of 3 plus 3, delta t minus 4 dt. Okay, if you look at this one, delta t minus 4. Okay, this delta t minus 4 means that the impulse response occur at t equal to 4, right? Okay, when t equal to 4, you may check that this P and Q, whether the A here is fall in between P and Q. So now let's check. Okay, T equal to 4. So it is in between. So the 4 is in between 2 and 5. So this means that there is some value for this integration. So we can find some value. So what is the value? Okay, how to find it? Okay, now you know that t power of 3 plus 3. Okay, so ft is t power of 3 plus 3. Okay. Now, your delta t minus 4 means that when t equal to 4, the value is 1. Okay, the value is 1. So your FA, okay, the FA equal to F4. And then, so you substitute the value of t with 4. Since the delta t equal to 4. So you have t power of 3, so it's 4 power of 3 plus 3. So this is 64 plus 3 is 67. So the integration 2 to 5 t power of 3 plus 3 delta t minus 4 equal to 67. Okay, now let's look at another example. To increase understanding, we add another example. In the integration from 1 to 3, exponent to t delta t minus half dt. Okay, so let's check. This delta t minus half means that the t is equal to half. The impulse response occur at t equal to half. So is it within 1 over 3? So it's not within 1 and 3. Because you are half. Half is this side, is less than 1. So this is out of range. Therefore, this integration should equal to 0. The answer is 0 because it is out of range. Okay, let's look at another example again. Integration 0 to infinity sine 3t delta 2t minus pi dt. Okay, how to solve this one? Okay, we can use the substitution for this part. We can set delta 2t. So we assume that u equal to 2t, okay, and then t is equal to u over 2, and we dt, we differentiate t, so it's the dt over du, we obtain half. Okay, now let's say if you have the t, you substitute the t. When t equal to 0, u should be 0. When t equal to infinity, u should be also infinity. Okay, now you know you substitute the 2t into u. So from here, 0 to infinity is a sine 3t delta, okay. From 2t, we change, oh, sorry. I should change also the t here. The t here should be u over 2 because we use this one. we substitute the t with u over 2, and then delta 2t minus, oh sorry, not 2t. 2t should be placed with u, so u minus pi, and then dt is du over 2. Now we take this 1 over 2 to the outside as a constant. So it's 1 over 2 integration sine 3u over 2 delta u minus pi du. We change to du. Okay. Okay, since it's integrate over du, so fu equal to sine 3u over 2. Okay, and then you still remember we have the formula, so ft delta t minus a dt equal to fa. Okay, now is the fu delta t minus pi du, so this is f pi. So fa is actually equal to f pi equal to, so this one will equal to a sine, you substitute the u with pi, so it's a sine 3 pi over 2. Okay, you press the calculator in the radian form, you get -1. So hold this, you will get -1. So by using the result of this one, so at the end, you obtain half. So this part is -1, so -1, you obtain -half. Okay, I give you another last example of this. Let's say 0 to 2 pi cos 3t delta t plus pi over 2 dt. Okay, so for delta t plus pi over 2 means that the impulse occur at t equal to -pi over 2. Okay, so let's check whether this -pi over 2 is within the 0 to 2 pi. So for, okay, if 0, this is a 2 pi. So -pi over 2 is not within the interval. Therefore, this integration 0 to 2 pi will be equal to 0 because it's out of range. Okay, so I hope you can understand, and thank you for watching.